Hello and welcome to the latest BYK-Gardner webinar. My name is John Kowalski. I'm part of the marketing team here and I'd like to welcome you. Today's topic is dispersion deep dive. About 3 or so weeks ago, we also did a webinar on media milling. I did put the link to the recording of that in the chat. Also, this is a approximately 45-minute presentation followed by questions and answers. If you have any questions, log them in the chat box located in the bottom right-hand corner of your screen, and we'll get to them time permitting. If we do run out of time, we'll get with you directly. So keep those questions coming. Also, we are recording this. Immediately following the presentation, you'll receive an automated link from our marketing team. Feel free to share that with colleagues, watch it later, grab some screen grabs, whatever you like. So with that, excellent presenter today, our resident dispersion and media milling expert, Mr. Andy Stummer. He's the managing director of VMA-Getzmann, the manufacturer, and also part of BYK-Gardner USA. So with that, Andy, it is all yours, sir. Welcome.
Thank you very much, John, and hello, everybody. Welcome to this version of Dispersion Deep Dive. This is actually really the first part of the dispersion process that we'll talk about today. It's the pre-dispersion process. As John had mentioned a few weeks ago, we actually did the media milling deep dive. We had to shuffle things around a little bit. This is why we are doing the pre-dispersion today. With that, let's go right into some overview. So the agenda is first, we're going to do a quick introduction about the company, VMA-Getzmann, the relationship with BYK and BYK USA, and then we'll go right into the dispersion process. We talk a little bit about the different lab scale, pilot, and manufacturing equipment that we offer. We speak a little bit about quality control and then the lab capabilities that we offer in Germany at VMA, as well as the lab we have in Wallingford, Connecticut at BYK USA. And you can see here, this is just an example of the broad product line that we offer, everything from lab scale. These are standard dispersers, the trade name Dispermat, that what VMA is known for, these benchtop units, and then basically work your way up all the way pilot. And then we have the large-scale Dispermat here. You see the Dispermat SC for manufacturing scale that actually has a media mill attached to it, a basket mill or immersion mill. So these units are fully exchangeable. We'll talk about the modularity of these machines, which is very unique to the VMA-Getzmann or Dispermat brand, meaning that you can turn a standard disperser into a basket mill, a vacuum system, or rotor stator system for different applications. You're not stuck with just having one piece of equipment. So here you can see the timeline. VMA started in 1972, so about 50 years ago, and Hermann and Elke Getzmann are the founders of VMA. And Hermann is still active in the business. He comes in 1 day per week just to ensure that the company still follows his design philosophy, and he wants to be kept up to date with all the new developments. So the business is actually still in family's hands. It's run by the two sons, Christian and Martin Getzmann. And BYK-Gardner and BYK USA, we have actually had the exclusive distribution rights for the product line since 1988. And just a quick story behind it. Our former CEO, way back in the mid-70s, early 80s, actually brought some of these Dispermats over from Europe and basically put them into the lab space in Connecticut. And then basically customers came in to visit and do tours through the lab. And they really liked the Dispermat design. The noise level is very low, very functional pieces of equipment. And the idea came up that we could basically integrate that product line with our Big Blue instruments and our physical test product line that we offer. and it's a really good fit. And that's how we became the exclusive distributor for that product line in North America since 1988. So the company, as I said, is still owned by the same family. They have about 100 employees scattered all over the globe. And they are known to make really great quality dispermats or dissolvers, different types of media mills, basket mills, or horizontal mills, as well as pop mills, and then anything from lab space pilot all the way up to production. And here you can see the picture on the bottom is actually the very first dispermat that was introduced a year after the company was founded. There are some customers that are actually still using the original dispermat today. So it really speaks highly for the motor technology. These are brushless step motors. And if you ever worked with a dispermat, you would immediately recognize that they are extremely quiet and there is nothing like them on the market. So with that, just a quick slide showing you the actual company in Germany. This is the VMA headquarters. The building in the middle, I don't know if you can see my mouse cursor, but it's the building in the center. That's actually new. They added on more production and design capability and giving us more flexibility for customer requirements. A lot of new end-use markets that came on board the last few years, where we're making specific machines for battery development, hydrogen application, specialty inks, and so on. They require a different design, and with that, we actually added that capability by increasing the size of the building and have more floor space for manufacturing as well as design. And then we also have a really nice laboratory space at the same site to do trials for customers and show them how the equipment works. We also have a pilot lab for large-scale equipment, allowing people to really look at different production options and scalability. So basically, dispermats are used for many, many different applications, but it was really born out of the coatings world and basically dispersing of pigments. So there we differentiate between organic, inorganic, or functional pigments, and then obviously special effect pigments, metallics, silver flakes, and so on that can be dispersed, but with more caution because you don't want to destroy these pigments and maintain the original shape. So it's a little bit more challenging, but our sister company, Eckert, that is a leader in special effect pigments, is using a lot of our technology to disperse and in some cases actually mill these types of materials. So why are we dispersing? Basically, we just want to have a better product. During the process, we improve our wetting. Dispersing is all about really breaking up invisible binding forces, or also called the Van der Waals forces. They hold these pigment particles together, these agglomerates, and we want to break that up and turn them into aggregates or primary particle size, which will then give us better color strength, better gloss. We'll have an overall cleaner looking product. But the real winner here is the improved pigment efficiency. By reducing particle size, we're able to save or help save a customer money by using less pigment in a formulation, really saving dollars by properly dispersing and then milling back to primary particle size, which will then also give us better product consistency. The formulation is definitely improved as a result of that, and we'll have a more consistent particle size distribution, and then that will also give us really good upscale results as a result of doing a good job when we're dispersing. If we don't do a good job dispersing, then we have a number of problems. So color change or poor stability of our color, the overall appearance is going to suffer. Flocculation of our pigments, which can actually be remedied by using the right additive that BYK USA offers. Sagging, leveling, settling, reduced gloss or even haze levels and separation are some of the issues that come up if we do a poor job. But overall, you're not going to have a really good looking product if you don't do a good job dispersing. So it's really important to remember that we want to have good stability. So pigments, they do require strong color fastness to be more stable and help with the fading over time. Generally, the brighter our color, the better the color will look. And then pigment size is a big contributor. The rule of thumb is the smaller my pigment particles, the cleaner my product, the better my color. And then obviously, again, it's a big factor is always saving cost and being able to use less pigment in my formulation by doing a really good job dispersing my pigments will help there. And then viscosity is also really critical. Usually we are looking between 2,000 to 5,000 centipoise to optimize our dispersing window. And usually the lower the viscosity, it's better to process the material and have a better looking product. If it's too viscous, it's more difficult, especially when you're milling. It's very difficult to get the material pushed or pumped through a media mill or circulate through a mill. So if the viscosity is lower or a product flows properly, then that's easier to do. And we're also able to put in more energy. Energy is really what's critical, is the amount of energy that we're putting in is really the driving factor in getting a really good quality dispersion. Also, an efficient dispersion process is possible by optimizing the viscosity. And we'll talk a little bit about that in a few slides, what we mean by that. So just remember that when we talk about dispersing, we are never talking about really a particle size reduction by destroying the pigment. All we are really doing is we are breaking up these invisible van der Waals forces, these binding forces that hold these pigment particles together. And all we want to do is really break up these forces. That's all we are doing and nothing else. We're not destroying the pigments ideally, like to keep them in the original shape. And these agglomerates, these larger particle clusters are turned into aggregates, and then we like to reduce them further to primary particles when that actually happens during the milling process, which we covered a few weeks ago. And then again, it's only the shear forces that are responsible for that separation and nothing else. And then selecting the right type of additive is very important to keep the particles in a suspended state and basically keep them from flocculating back together, which sometimes happens if the formulation doesn't include the right additive or dispersing agent to keep them in a suspended state. This is just a slide showing you what the different pigment classes look like under a microscope. Just giving you an idea what that looks like. So this slide is really nice in the way it shows like these different building blocks. So basically these larger blocks on the bottom here, we call them agglomerates. And these are basically a lot of pigment primary particles that are bound together by these van der Waals forces. And when we are dispersing, we are breaking up these forces and we're turning these into aggregates. So these are just smaller blocks. And then from the aggregate level down to the primary particle level, this is when we would actually use a media mill, either a basket mill or a horizontal mill, for example. Some people use 3-roll mills, old school, but that will really help to get these aggregates down to the primary particle level. So the dispersion process is really the wetting of our solid particles. That's the first step. The mechanical breakdown of the agglomerates and then the aggregates into primary particle size. And then again, the stabilization of our particles in our slurry. So this is a really nice visual slide here showing you the process. So wetting with the cow's blade, pre-dispersing all with the cow's blade, and then we mill anywhere between 10 to 30 microns of particle size is when we kind of reach the limit of what a dispersing blade can do, and that's when we're actually grinding or milling. And then again, the last picture on the right here kind of shows you the stabilization of our pigment particles in our slurry with the right additives. Okay, so here is a really important slide kind of giving you the breakdown of at what point would you start the milling process. So again, the threshold there is what we find with many, many years of experience is that once you reach about 10 microns of particle size, the dissolver or the cow's blade is no longer efficient enough to continue to break up the binding forces. We need more energy. And the way that we can put more energy into our mill base would be by using a different type of media mill. Again, horizontal mills or vertical mills or anything of that nature would help us to really reduce the particle size below 10 microns all the way down to sub 100 nanometers for very specific applications. This can be achieved by selecting the right type of media mill. But remember that anything less than 10 microns, you're not going to have much luck sticking with the dissolver or a cow's blade. That's when we really need to start switching over to a bead mill. So the dispersion process, again, is two parts. We have the pre-dispersion process, which we will focus on today, where we use the dissolver with the cow's blade. Very important to remember is the actual peripheral speed or tip speed. We want to be anywhere between 18 to 25 meters per second. That's the optimum dispersion window, as we call it. And then when we are fine dispersing or milling or grinding, our tip speed is anywhere between 10 to 16 meters per second of rotor speed or milling disc speed. So it's slower when we are milling, but we also have media in the process to help us put in more energy and basically really reduce the aggregates down to the primary particle size when we are milling or grinding. And for that, again, we have different types of media mills, vertical bead mills. We call that an APS system, basket mills, our TML or horizontal bead mills, where we have the SL for lab or RS for manufacturing scale. But remember, dispersion process, always two parts. Pre-dispersion, first step, absolutely necessary and critical, and then the fine dispersion, milling or grinding as the second step. So what is important in our first step when we're pre-dispersing is the dissolver disc ratio to the vessel diameter. Usually the rule of thumb is about 1/3 of my diameter of my vessel should be the blade diameter. There is a nice table. We also have it online. You can look at it here. That kind of breaks it down. So there is not one blade that fits all different sizes. There is a range of blades. So for example, if you take a 1 liter container, 1000 milliliters, it's the fourth one to the left. For example, our optimum dispersion blade diameter would be 50 millimeters. It's kind of in the middle. So as my viscosity of my material increases, I can also increase my blade diameter. And then low viscosities, I can reduce my blade diameter. So you can play around depending on what works for you and what doesn't, kind of dial in the right blade diameter. And we'll talk a little bit in a few slides what we're looking for when we optimize our tip speed, 18 to 25 meters per second, and what we actually should be seeing if we have the right blade diameter to container size ratio. Okay, so this is a really important formula, and you may want to write that down. And this is actually the tip speed formula. So we have our tip speed is actually the RPMs times pi times the diameter of our cow's blade or dispersing blade. And if you want to figure out meters per second, then you would actually express the diameter of the blade in meters. So if it's 50 millimeters, it would be 0.05 times the RPM and times pi 3.14 and divide everything by 60. That will give you the meters per second a calculation of our tip speed, and you want to be between 18 to 25 to have the optimum dispersing window. So you may want to write it down, but we share the presentation so you can review that later. Some of our high-end machines actually display that on the actual control panel, and the lower cost machines, you'll actually see the RPM, so you'll have to calculate that value. But that is actually, I would say, probably the most critical, one of the most critical values to dial in the parameters for optimizing the dispersion process. So then the visual cue, as I mentioned earlier, is called the donut effect. So the donut effect is really called that because what you should be seeing when you look inside of the container during the dispersion process, if you run between 18 to 25 meters per second, ideally you should see the formation of a donut, and that's where that term comes from. So if you see that, you can probably rest assured that you dialed in the proper tip speed, you're putting in the right amount of energy, and that the blade diameter in relation to the vessel diameter is correct, and you're absolutely seeing a good looking donut. That means you're efficiently pre-dispersing your slurry, and you're getting ready to prepare it for the milling process. But ideally, this is what you want to see. So if your viscosity is between 2 to 5,000 centipoise, then you really have no problem seeing a donut. If the viscosity is below that, usually what happens is there is not enough viscosity for a donut to really form. So it doesn't mean you're not pre-dispersing. It just means that you really don't see the donut because the donut will collapse as soon as it will try to form because you don't have enough viscosity. If the viscosity is too high, then it's also more difficult to get a donut because you're dealing with more of a pasty slurry in some instances, so the donut wouldn't really be there either. So if you optimize the viscosity at the tip speed, the geometric consideration, meaning blade diameter to the vessel ratio, then you should really see the donut. Okay, so here is actually what's happening during the process. So we have the cowl's blade with our teeth at the edge of the blade. And these teeth really are causing the shearing action to break up these binding forces and reduce the agglomerates down to the aggregate size. You would actually see the same thing on the bottom of the blade. I'm not sure whether it's not on this picture, but it actually also happens below the blade as it does on top of the blade. So this is where you're actually shearing the material and where the breakup of the binding forces takes place. So if we have an optimized dissolver batch, as we like to call it, we want to see that donut. And then in this case, we're running here at 21 meters per second, and we are putting in about 850 watts of energy. So that we know, okay, this looks pretty good. We run this probably between 15 to 30 minutes. That's usually a good time frame for pre-dispersing our slurry before we would move over to a media mill. But then sometimes it happens that we have 21 meters per second, but our energy input is very low, okay, and we don't really see the donut. So what happened here is probably the viscosity is so low that the donut would collapse, and we are not able to put in a lot of energy because we don't have the viscosity, even though we're running the same tip speed. So I would suggest in this case to either change the blade diameter or play with that, or maybe try to reformulate the product to kind of change the viscosity and see if that will help bring it up, and that will allow you to put in more energy. And by putting in more energy, that you would probably be more likely to see not only a quicker pre-dispersion step, but also possibly also that donut. Then we have a case where we don't have a donut at all. We're still maintaining the 21 meters per second. We're putting in 900 watts of energy, but no donut is visible. So in this case, probably the viscosity is very high. So we're able to put in a good amount of energy, but because of the viscosity, we're not able to see the donut being formed. Doesn't mean you're not pre-dispersing, it just means you're not seeing a donut, but you optimize the tip speed and you're putting a good amount of energy. So you're really processing the material. It's just too viscous to really have a donut effect. So these are just some things that you can look for and try to optimize maybe the formulation. Or again, you could play around with the blade a little bit. But when the viscosity is really high and you reduce the blade diameter, and usually what happens is that the blade would just spin inside of our slurry and not really move the product. So the higher the viscosity, you really need a larger blade to really start moving the product around the container and put in sufficient energy. So by reducing my blade diameter, I'm also going to reduce the amount of energy I'm putting in. So that probably would then mean that you'll need more time to pre-disperse in that case. Okay. So to optimize our dispersion result, in this case, we talk about the pre-dispersion. So the duration of our pre-dispersion, again, 15 to 30 minutes. Usually that's the rule of thumb. Anything more is not really needed. So we should be able to get there after 30 minutes to be between 10 to 30 microns of particle size before we start milling. Again, the donut effect, the visual cue, tip speed, very important, 18 to 25 meters per second. Our higher end machines will show that on the display. Customers really like that when they can see it and not always have to calculate it. And then the geometric consideration, again, diameter of our blade versus vessel diameter, and also the design of our blade. There's a lot of different type of impellers out there with different set of teeth, different coatings on it. Certain materials are not compatible with stainless steel, especially when you're talking some of these new end-use markets like batteries, slurries, or for electrolyzer applications where these materials cannot be in touch with any kind of steel. So there would be cross-contamination. So there is also important to choose the right material off the disc. Mill base filling ratio, we recommend about 50% of a fill ratio with the container, anywhere up to 70%, but not less than 40. So 50 is optimum. If we go above 70, then we probably see some spilling when we put the energy in. So you don't want that. If we don't have enough mill base, then it's difficult to oscillate. Sometimes when I just put the blade at the perfect height inside of our container, and if we don't have enough mill base, it's difficult sometimes to find the exact sweet spot. So 50% is really ideal. Formulation, of course, pigment filler concentration. When we are dispersing, not so much pre-dispersing, depends on the viscosity, but when we're milling, it's really critical is to try to keep the temperature as low as possible and use double wall containers and cooling. When we put in energy, and before you saw like 850 watts, 21 meters per second, that's a lot of energy that we are putting into a mill base. That automatically will bring up the temperature of our slurry If we are dealing with solvent-based products, obviously, then you can, deal with the flash off or evaporation of our solvent when it gets too hot. It could also be dangerous. So cooling is really critical, and we want to keep the temperature as low as possible. And then again, the right type of additive, dispersing additive or wetting agents, defoamers, are sometimes very important. There's certain products that tend to foam up because when we have a spinning blade, we're pulling air into our mill base, and these air bubbles sometimes lead to foaming issues, and then people sometimes have problems transferring the mill base from one container to another container, especially if you want to go from, in manufacturing scale, you want to go from pre-dispersion batch, and then you want to immediately move it over to a media mill, and then you have to deal with all the air inside of the container. It can make it a more difficult or tedious process to move product from one container to another if you have a lot of air. For that purpose, we also have vacuum systems that can help you, or the right defoamer can also do the trick. Okay, so it's really important then to remember that with the dissolver or Cowles blade, we have only limited amount of energy we can put in. We're not using any media. So it's only really to de-agglomerate these particle clusters, and we're not getting down to the primary particle size. We're just using a dissolver. And it is a critical step to do before milling, because if you go straight to a mill, you're most likely going to clog up the screens or a dynamic gap, and then you won't have any flow of your material in and out of the mill. So it's really important that you use a dissolver first and pre-disperse. You're wetting all the particles properly. So that's really, really critical, and it is a necessary step for any dispersion. And then if you stop after the dissolver stage, again, you're not going to have a very good looking product. Your color strength is going to be limited. You're also going to waste a lot of unnecessary resources because your pigment particle size is still too high to really be efficient. So it's not ideal if you want to save cost. You always want to try to get the particle size as small as possible. So you really should be medium milling if you try to have a better looking product and try to save money. Bead milling is critical. With that, we can put in a lot more energy. It allows us to go down to the primary particle size, down sub 100 nanometers, not unusual, especially for these new end-use markets. So even automotive coatings require really, really fine pigments, a small particle size that makes these automotive coatings really pop and give them a really strong and beautiful appearance, is because they are really milled really well. So that's critical to remember, and the difference between the dispersing and what's actually happening when we are milling. So with that, this is just an example of a lab scale Dispermat. It's shown here as a dissolver. Again, giving you all the different capabilities to upgrade to a media mill on the same machine. This here, as you can see, has a really nice control panel. We call it the C technology, allowing you to basically store batches by name, recall them at a later time. You can store all the different critical variables, your speed, your energy input, your tape speed. You can also have a temperature limit. So if your certain products can reach a certain temperature, you can build in thresholds so that the machine will behave differently once it reaches a certain temperature, either run with a different or lower energy input or different speed, or that the machine will shut down altogether once it reaches that temperature threshold to really protect the material. It's an excellent tool for upscale. So a lot of customers really like the C technology in a lab setting because it allows them to store these different products and then go and use the same technology to go from lab up to manufacturing. So we have a very seamless process from lab to manufacturing by using the C technology. It's very helpful and will give you excellent upscale results that are very repeatable from batch to batch. We also offer explosion-proof versions, especially for solvent materials, and then software for PC, so you can download or transfer the data. You can look at the actual dispersion process in real time in a graphical interface on the computer or on the display right here. So each of these variables, your speed, your energy input, your torque value, or temperature, will all be expressed in a trend line, and then you can see, okay, am I effectively milling? You should see an increase in the energy you're putting in, what dispersing. If my particles size becomes smaller, I have more particles, and that means usually my energy will increase if I'm running with constant speed. So that's all visible on the actual graphical interface. So these are excellent, tools for upscale with the C technology. We obviously are very proud to offer a universal dissolver by giving the customer the ability to use it as an homogenizer by basically adding a mixing blade or a propeller blade onto the same disperser. We can use it as an emulsifier. So some people would like to use a rotor stator. That's very helpful, especially if I try to blend products together like oil and water, or people that make tinctures or so on. We see it also for battery development in some cases where people prefer a rotor stator over a medium mill. And that means that the same piece of equipment that was a dissolver in 1 minute now can be a rotor stator, but just by swapping out the head. Or use them as a disperser with the cowls blade, or adding a basket mill on the same machine, for example, makes these dispermats extremely versatile and unique in the industry. So you're not buying just one piece of equipment that can handle one task. The idea is to really give you full flexibility and many options to design a project or a process around the equipment. For example, if you want to run vacuum, you can get a CDS system. Or even for very pasty materials, we offer a wall scraper system called the ACS, or a vertical bead mill, APS, as I mentioned earlier, the rotor stator, or a basket mill. So all these are optional attachments that can be purchased at a later time, giving you full flexibility with one piece of equipment. No more need to buy two different sets of equipment for dispersing and milling. Now you can do everything on one machine. We have an LC line, which is our economy line. We are actually in the process of phasing this out and replacing it with the new CV line that we're coming out with, introducing that next year. But basically just giving you the option to dial in the speed. I'm not personally a very big fan of this design for one reason, and it's that you have to manually raise and lower the motor, the shaft, with that lever right here, giving you the option to raise it and lower it and put it in the correct position. Now, the problem I see with this design, and I'm very open about it, that you cannot really oscillate. So it makes it very difficult. Also, if you're not very strong, then this is not ideal. You have to do this manually. So I much more prefer the CV line, which is actually has an automatic up and down button, so makes it very easy for the operator. Again, we use brushless step motors, and I can't stress it enough. If you have never worked with a Dispermat, please come to our lab in Connecticut, turn one on, and you will hear the difference compared to any other disperser or mixer on the market. They're so quiet. Even if you're running at top speed, you can hardly hear them. And the technology is so good that they have hardly any vibration. So you can put a quarter on top of the motor and it will not bounce off. That's how smooth these machines run. And we have customers that are running the original motor for over 35 years now, and we never had to replace any bearings or anything. So these are really, really good motors. On the CV line, we give you also the ability to look at a torque value. Again, electronic up and down, timer function, variable speed, and also the ability to completely accessorize it. Again, that modularity approach for adding milling systems or vacuum system holds also true for our CV line or the LC that I showed you before. So they're all modular. The CN is kind of our middle of the road Dispermat. What is great about this particular machine or model series is that it's very scalable. So you start out with the CN, 10, for example, which is the smallest lab scale one we offer for like a quart or half a quart. And then you can go in the same model series. We have a CN 100 that allows you to make pilot size batches, and you stay within the same product family, giving you, the same control capability, lab and pilot, speed, torque, temperature, timer. Again, full modularity, and again, same motor technology, extremely quiet. This is the same CN, just larger, same technology, bigger motor, bigger stand. So seamless scalability from lab to pilot, and then we can also scale it very easily to manufacturing grade size with the same technology. Then we have the AE. I showed you that earlier. This is our premium line with the C technology package that allows you to store the data. Again, have different batches by name, and then see everything on the display, the actual dispersing process and the graphical interface. We can run it with constant speed, or we can run it with constant power. Constant power is interesting because instead of dialing in a certain speed, I can dial in a certain amount of energy. Let's say I want to run this with 850 watts. Then my machine will automatically adjust the speed to always maintain the 850 watts. So if my viscosity increases, my speed will decrease because I'm maintaining the 850 watts. So if my viscosity decreases, my speed would increase as I'm maintaining my 850 watts. Now that allows me to precisely calculate the amount of energy I would be using to disperse X amount of product in a certain amount of time. And when I upscale, I can figure out, hey, how much is it going to cost me to produce this batch of material? If I want to make, let's say, if it's 800 gallons, I'll be able to calculate that with if I'm running with constant power. And then obviously the WinDisp 7 is a software package. We're coming out with a new WinDisp that basically allows you to port all the data over to a computer and look at that on a PC. And then again, we have the explosion-proof models. On the AE, again, it's very scalable all the way from lab, pilot, and then we can go up to manufacturing. So it's really nice design and very safe. I just want to mention that, safety is paramount for us, and all of our Dispermats come with a number of safety features, starting out with that container clamping system that you can see here on big Dispermats or small ones. That wheel right here on the right-hand side on the clamp actually is used to loosen or tighten the container. And there's a sensor back in there, and it will measure the pressure. And if the container is not snug or wiggles around, the machine will show that on the display and it will not power on. We don't consider it safe if the container can move around. It also means once it's fully locked in place is that the blade will always be perfectly centered. There is no way for a blade to touch the container wall or anything like that, giving you other problems or potentially hazardous situation. 20,000 RPM blade hitting a stainless steel wall is not always good when you're running with solvent-based products. So safety is key there. The other important safety feature is what we call the working area threshold. And all of our diplomats have it. So if I go back here on the smaller unit, so we can set an upper and lower threshold electronically on the control panel, depending on the container size. And what that does, it allows us to safely operate the dispermat when it's running in between these two thresholds. So if somebody were to inadvertently lift up the blade or the shaft while the unit is running, it would automatically stop at the top threshold, and you would not be able to lift up the shaft while the machine is running. So you'd have to shut it off, and then you can lift up the shaft so that there is no spinning blade outside of the container, potentially hurting somebody, or you have product flying around your lab space. It's really critical in all the machines, but on the small ones where a lot of people like to operate without a cover, this is really a safety concern. So the threshold setting is very, very important. On the larger machines, you can see they come with a cover, so it's not as it can be dangerous also if you run it without a cover, but because it's closed, so you're unlikely to have a spinning blade outside of the container. So, and then the same threshold setting for the bottom, H2 we call it, so that there is no way for somebody to, when you lower it, you can't always see the exact height of the blade in the container when you have a mill base in there. So that way you stop the blade on the bottom at a certain height, so it won't ever bottom out and hit the container bottom. That's also really important. And then we also offer all of our diplomats with this shaft protection pipe that goes over the shaft. You can see it right here. This is adjustable. That means that you don't have any moving parts outside of the container that could possibly injure somebody, or somebody could get tangled up, on the shaft, leading to an injury. So safety is really, really important with the design. So then we offer production scale dissolvers. So this is the Dispersion SC, again, very modular. So giving you the ability to retrofit a basket mill on here, do this with the quick change system called QCS for our manufacturing size machines. Really perfect for somebody who has limited space in the manufacturing area and wants to basically produce an entire batch, dispersing and milling on one machine. So this is possible with the Dispersion SC and the dissolver / basket mill combination, and the quick change system, allowing you to really move quickly from a dissolver over to a basket mill. Here we have a vacuum version. Again, some customers really have problems with air, and by being able to remove any air bubbles, which think about the like in small, tiny air mattresses. And when you're dispersing or milling, they act like these air mattresses. They will act as buffers. So the blows of our media are basically reduced, meaning might have reduced shear and reduced energy input really to properly disperse. So by having a vacuum environment without air bubbles, I'm basically able to disperse quicker and put in more energy and mill more efficiently, or disperse more efficiently with a vacuum setup. And then product transfer is also improved because of that reason. No foam. So then we have the quality control aspect. So on the left here, you see that C technology, very well laid out. On top, you have your RPMs, top left. Then you have the amount of energy you're putting in. As you can see, the red dot is next to the RPM, meaning that we're running here with constant speed, and the machine will adjust the power that it needs to maintain that speed. But again, on the C technology, it can also run it with constant power, where then the machine will adjust the speed. Then below that, on the bottom, we have our torque value expressed in Newton meters. Top right is actually the tip speed, that critical value we talked about before. Our temperature in the middle there. And then on the bottom right, we have the timer function, allowing us to program the machine to shut off after a certain amount of time or run with a different speed or different energy input once we complete our process. And then on the right side, very simple control panel. It's an example of a manufacturing scale version, very simple. We have explosion-proof versions. That is also something that we offer. And then we have the customization option. So this is a Siemens control panel. You can program everything the way you want it for your process. And if you like to integrate a scale, for example, and weigh all the material right on the machine, because you can actually put the machine on a load cell, then that would help you there. And then you basically have all the critical information, raw material information, loading, so on, as well as all your dispersing and milling parameters on this HMI control panel. Siemens makes those. Unfortunately, right now, they have really long lead times, and I think it's like 10 months now for that control panel option. So here it's just an example of the controllability on the C technology with our cutout values. So in this example, we set our maximum temperature is 80 C, and then you can set up the machine stops once it reaches that limit, so it turns off, or we can program it to run at a different speed or different input once that temperature limit is reached. It also allows you to program 2 warning stages. So if it, let's say, reaches 70 C, it will give you a warning, and then again at 75 C, it will also give you a warning. And then on the bottom here, just giving you an example of a color blue 1, and then all the parameters as they are stored for that batch. So the next time when you're running blue 1, then you can use exactly the same parameters, H1, H2, the settings, the threshold settings, the container diameter, the diameter of our blade, the time, the temperature cutoff values. And also on the new one, it actually shows us here the actual height of the blade in the container where we're actually operating. So in this case, at 14 millimeters is actually the height of our dispersing tool. So if you want to replicate blue 1 in the future, all you do is recall it, and then you allow it to create the same batch every single time, so that the Dispermat would be giving a very repeatable product. And then again, we have this visualization. It looks a lot better on, this is WinDisp 7, WinDisp 10 is not out yet, but on the new WinDisp, this will be very nice and graphic and give you a beautiful visualization of what's going on with the dispersion process and the different trend lines. We can also do a net power calibration, basically reducing or eliminating any machine noise when we're from our data. So that means as the Dispermat, when the Dispermat is turned on and it basically does a dry run or runs, it already uses energy or torque just to move the shaft. And by doing a net power calibration, I can reduce all that to a 0 value. That means when I'm making my product, then all the values like my torque, my energy input, and so on are only reflective of my material and not because of the machine noise. So that could also be very helpful, especially when you're upscaling and you have a very precise product. And you need to be really mindful of all the values or all the influences to the respective values. So the net power calibration is a good tool to eliminate that noise. An example of Windows 7, it's kind of cluttered, so we are phasing that out, but that's what it looks like on a PC. But the Windows 10 will look a lot better, and then we should have that hopefully next year. That will work with the C technology. Here is a picture of our applications lab in Germany at VMA. A lot of different pieces of equipment, giving customers the option to try out the different accessories, basket mills, or rotor stator heads or vacuum systems, and then use that data to upscale. We also have a nice lab in Connecticut. We have a lot more equipment in there now, so this is an older picture, but we actually brought in the new AE6 with the C technology, and we have the new SL horizontal bead mill also with the nano kit. So we have all these different milling options and dispersing options, as well as the rotor stator available. And customers that are interested in learning more about our equipment, really like to invite you to come up there, bring your product. If you're interested in checking out how your product performs using a Dispermat and what results we would be getting, the Wallingford site is really a A-class lab facility. We'll be able to show you all these capabilities. We'll help you to scale up if you're interested in our production scale equipment. The beauty of having the lab with BYK USA is that we have chemists on hand that can assist us in improving formulations and optimizing the formulation to the Dispermat. So we are not only a company that sells you, quote unquote, a hardware solution, but we want to really provide you a complete solution and give you also recommendations on how you can formulate a better product and process the material the most efficient way with this equipment, rather than being somebody who just sells you a piece of hardware and kind of leaves it up to you how you design your formulation and then do process improvements. Also, some people just want to come in and check out the equipment. That's a possibility. And then also bring in maybe people that you just hired, or somebody needs to learn more about dispersing and milling. We can offer that also as a training location and give you that option also. So with that, I'll turn it back to John. Thank you very much for joining me today.
Yeah, lots of great information, Andy, as always. And definitely, those on the line, look for the recording that'll be sent out right immediately following this, so you can go through it at a slower pace. I know that was a lot of information to cover. We do have a couple questions here, if you're good, Andy. Are bead mills typically used for standard architectural coating formulations? I've typically seen that Cowles dissolvers are sufficient even for TiO2 grinds for such formulations.
So that's actually true. I mean, so there is a difference in what type of end use market that we're looking at. So architectural coatings, most of the pigments are in the low micron range. We're not talking nanometers. And so if the materials that have already been pre-dispersed, then usually a Cowles blade can do the trick. However, these companies that make these architectural coatings, a lot of times they do their in-house dispersions. And then basically then they will make their own dispersion and then use it when they make the batch. When they make the dispersions, usually they would do milling depending on the color or pigment family, but they definitely, for the pre-dispersion, for the development of the actual pigment slurry or dispersion, they would definitely do milling there also. We sell a lot of these type of basket mills, for example, not so much the horizontal mills, to the architectural market. A lot of the companies that make the TiO2 slurries are customers of ours, and they all do using a basket mill to really grind down the TiO2 slurries. But everybody has different requirements, so.
Excellent. Okay, another follow-up to that. What types of applications or formulations always require the bead milling after the pre-dispersion? For example, I would say, battery formulations?
Well, so that really depends on your particle size spec. So again, anything less than 10 microns, we would recommend that you do milling, especially if you have no pre-dispersed material. And then it's really up to you what technology. I mean, I would say that a lot of people are moving. If you're if you can stay above 500 nanometers and you have a good viscosity, again, 2 to 5,000 centipoise, it can be a little higher there, it's okay. I would say that the trend definitely goes towards basket milling because of the efficiency of the milling process, the ease of use, and also the maintenance of the equipment. If you need to go below 500 nanometers, then unfortunately you will be milling with the horizontal media mill, as this is the most efficient way to get to those particle sizes. Other than that, I would suggest basket milling is really a fantastic way of getting a good grind. Very quick color changes are possible. Very low maintenance compared to horizontal mill. Horizontal mills take a lot of time to disassemble, clean them between runs, also basically maintain them properly with different O-rings, washers, seals, screens, and so on. It becomes a lot more complicated. When customers actually find a way to utilize basket mills, they're super happy. We have a lot of customers also that are moving off from 3-roll mills that came to the lab to do a case study. And just one example, we had a customer come in for an ink application on a 3-roll mill. Would take him 18 hours to mill or grind a pigment on a 3-roll mill. We were able to do the exact same product in 45 minutes. So that's really unbelievable of how efficient the basket mills are.
Yeah, that is truly amazing. I remember you saying that in a meeting a couple of weeks back, and just amazing.
And whoever asked the question, I mean, we're not speaking empty words. Please come into the lab, and we'll prove it out. So
no, that's great. And if anyone has questions, if anyone wants to talk to Andy or his team, you can always just hit reply to any of the automated marketing messages, and we'll get it to him and the technical experts here at BYK-Gardner.
And John, post a link to our YouTube channel.
Yes, that is in the chat in that opening sentence or opening paragraph that I put up. At the very bottom of that first message is the link to the media milling deep dive webinar a couple weeks ago. So this is really the first part of that that whole package. So you can go out to that YouTube channel. There's also a quick video showing the Wallingford lab, as well as some other presentations that Andy's given. So take a look at that. If you have any questions, we're here to help you, or to at least trial and test your applications, your materials on the equipment, and we can see how it goes.
I want to just mention one thing. I see that there's still a good audience here, online. One of the key advantages here, basket mills, is the quick color changes. That always comes out.
Oh, yeah.
So when you look at the process, right? So I take manufacturing, for example. So you pre-disperse, right? Okay, that's one step. Usually I'm moving then, after I'm done pre-dispersing, I'm moving it over to an immersion mill, as they're called by some manufacturers. We call them TML basket mills. And then you would run your product on the mill. Now, normally what happens is when you complete it there with the milling process, now you take the mill apart on this machine and you're cleaning it, and you're basically tying that machine down to a cleaning period that can last anywhere from 1 hour, 45 minutes, to maybe even longer, 2 hours, depending on the design. So we came up with that quick change system that really minimizes any type of downtime. So basically, you're running your blue, pre-disperse, you mill on the basket mill, your blue. Now that, let's say your next color would be a yellow. Instead of cleaning everything, you just remove the blue, do a quick flush, and then you just pop on a different basket, and then you run your yellow. So basically what customers are doing is they're buying one production scale Dispermat and buy a number of different basket mill attachments and dedicate them to different color families. That means you're always producing and you're never wasting any valuable time or downtime with the equipment for cleaning. So this is a huge advantage in terms of processing performance, and saving companies a lot of money with downtime and also maintenance of the equipment. Now you have only one machine versus multiple pieces, or also space savings, so that's another big one. So look at that. We'd be glad to discuss this with you and show you real examples of integration designs and all that. So we'll be glad to talk to you about that.
Yeah, and I'm glad you brought that up. That quick change option is just a huge advantage. For folks out there, one thing that I love about this offering is it's modular. You can grow from pilot all the way up to production, and use the equipment, and it just adds on. So that's something to think about as well. So with that, thank you for joining us today. We appreciate the time. Thank you, Andy, for the wealth of knowledge, as always. Every time I hear you talk, I'm always learning something. So that's good. Hope everyone out there learned something as well. And we look forward to seeing you on future BYK-Gardner web seminars. So with that, have a great day, and happy holidays if we don't talk to you. We'll see you.
Thank you, everybody. Welcome. See you next time. So appreciate it.